Macros are a feature of Scheme that allow you to define new special forms in the language. In Python, we have a certain inventory of expression and statement types. And the same was true in Scheme. We had define, lambda, if, cond, and, or, etc. Everything else was a procedure. Now, macros allow you to extend that inventory by inventing new kinds of special forms. That means that we can change the way the language works, inventing new ways in which the flow of evaluation proceeds through a program. Sounds fancy, and it is. It's the kind of feature that makes people fall in love with Lisp programming. And the reason it works well in Lisp languages like Scheme is that it's easy to view code as data. Programs are just lists. Macros perform code transformations. So the way that we'll invent new special forms is to describe how to take the parts of a special form and construct a regular piece of Scheme code out of them, and then evaluate that Scheme code. So a macro is an operation performed on the source code of a program before that source code is evaluated. Macros do exist in many different programming languages, but they're by far the easiest to define correctly in a language like Lisp, where the code is just data. In Scheme, there's a special form called define macro that allows you to define a transformation over the source code for the special form that you're trying to invent. So here's an example of a macro called twice. You can see it looks a lot like a procedure definition, but the way in which a twice expression gets evaluated is quite different. The content says that when you twice an expression, you build a list that starts with begin and then has that expression twice. Once you've defined this macro, you can twice anything. And here, we're twicing the expression print2. What happens behind the scenes, because twice is a macro, is that it evaluates the body of the macro on the expression you've typed here before that expression ever gets evaluated. So we construct a new expression, begin, print2, print2. And then this expression gets evaluated, which means that it will print 2 twice. Now there's something interesting going on here. If twice were just a procedure, however it were defined, print2 would have gotten evaluated before twice were ever called. And that means 2 would have been displayed once, and that value 2 would be gone, because once you print, you can't get back the value. So there is something that twice can do that a regular procedure can't do, which is to take this expression and duplicate it before it gets evaluated, and then evaluate it twice. So the evaluation procedure of a macro call expression in general, like this one, is that we evaluate the operator sub-expression. If that evaluates to a macro, defined by the define macro special form, then we proceed a little bit differently than regular procedures. We call the macro procedure on the operand expressions without evaluating them first. Then we evaluate the expression returned from the macro procedure. So macros take in expressions and return expressions instead of taking in values and returning values. So let's talk a little bit about print. When I print 2, I see 2 on the screen, but if I define x as print 2 and then I look at x, I see that x is nothing. Once you've printed, the 2 is gone. If I wanted to print 2 twice, then I could write print 2 and print 2. But in order to put that into one expression, I need to use the begin special form. The begin special form just says do all of these things. Let's say that I was stuck with only procedures, and I wanted to define twice. I'm going to write the same body that I had on the slide. Begin, the expression, and then the expression again. Now twice print 2 doesn't work. I get 2 displayed, and then I construct an expression that says begin none none, the value of print 2. If I wanted to construct begin print2, I would have to quote this. So it's not like it's impossible to do this with the procedure. I just have to think about quotation in order to make sure that this doesn't get evaluated in advance. But even this version hasn't printed anything yet. The only way to print would be if I evaluate the result of calling twice on the quoted print2. The idea behind macros is that this quotation and evaluation procedure is taken care of for you. So if instead of defining this as a procedure, I define it as a macro, then instead of typing twice quote print2 and evaluating the result, I can just twice print2 and I see 2 displayed twice. So something simple and something profound has happened at the same time. The simple part is that all it does is make sure that print2 doesn't get evaluated, for example by quoting it, passing in the expression to twice, and then evaluating the result. The profound thing is that we've changed the way the language works. Twice is now the kind of special form that doesn't involve evaluating the arguments first, and that means we have complete control over when and how things are evaluated inside of a macro. Let's look at how this can be useful. Let's say I want to define a procedure that checks whether something is true or false. If I pass in a value, I can write if the value is true, then I passed the check. Otherwise, I failed the check. And if, for instance, I had x, -2, and I wanted to check that x is greater than 0, I would have failed that check. So this is a reasonable way to add little tests inside of your Scheme program, but unfortunately it doesn't tell you what failed when something failed. It would be nice if it said, here's what failed. But in order to do that, we need access to the expression that was evaluated instead of just the value itself. So let's define a macro. First, we'll just name it check in order to be consistent, but this doesn't take in a value, it takes in an expression. Instead of just writing down what gets evaluated, I have to construct this expression piece by piece. You check expressions by building a list which contains if, and then it has the expression that we want to evaluate, and then it says either passed or failed. Here I've double quoted to say that I want the result of evaluating this to be this, quote passed. And now I've built a macro that behaves just like the procedure that I had before. So if I start Scheme and I load this file, and I define x to be -2, and then I check to see is it the case that x is greater than 0, it will say failed. So I've done all this work to define a macro. It was slightly more complicated than the procedure, and it doesn't do anything new yet. But we could get it to do something new by not only saying failed, but also saying what expression failed. So in the case that this fails, I'm going to build a new list, and it's still going to say failed in it, but then it's also going to show you the expression. Now we run the whole thing exactly as before, define x to be -2, write down what looks like a procedure call, but in fact it's not a procedure call, because when it fails, it tells you that it failed, this is a false value, but also the expression that caused it to fail, and that's something that would not be available to a regular procedure. Before we conclude, let's quickly look at the expression that was constructed by this macro. You can do that by removing the dash macro, and now we just have a regular procedure. This regular procedure can take x as -2, but when it's called, we have to explicitly quote the expression, as if we were calling a macro. Is x greater than 0? Constructs the following expression. If x is greater than 0, then it just says passed. Otherwise, it builds this list. failed, and then the expression. If I were to evaluate that, then I would get the fact that it failed. But of course, if instead x were 2, and I evaluated the same thing, then I would see that it passed. So we've built from scratch a macro, a new special form called check, that checks whether an expression evaluates to something that's true or false, and when it evaluates to false, it shows you the expression.